So we want to do some examples of solving trigonometric.
We can just do the examples that you're pretty sure are going to show up on the test.
Okay. Let's examples
Really
of
all I'm worried about.
trig equations. Okay, let's do those then.
Yeah. It's always tomorrow.
So let me refresh your memory as to what the issue was. If the question comes down to solving sine x equal to a is some number, maybe one of those famous numbers, maybe just any number between 1 and minus 1. You want to get one answer which perhaps either you get from memory or from your calculator. We said, again, to get some help from the unit circle, to get the sine of an angle, sine of that angle, if you have an angle theta, its sine, its shadow on this vertical. So this other angle shares the same sine with this one. And what is this other angle? This other angle is going to be pi minus theta. Both of them are fine. In addition to that, if you go any number of rotations around the circle and stop at the same spot, those also have the same sign as what you got here. So x could be sine inverse of a, which your calculator is going to supply to you an answer in the first or fourth quadrant. X could be pi minus sine inverse of a, which is going to be its supplement. In addition to this, you can go any multiple of whole circle. Here also any multiple of the whole circle is fair game. So you get two series of solutions. One other way of looking at the same situation is to remind yourself what the graph of sine looks like. So here's a graph of sine. You have sine of something given to you as some quantity a. This is your a. You are asking what was the angle that led you to this height. Okay, let me find that angle. I draw this horizontal. See where I cut my picture. This is the angle, theta, perhaps. This is its supplement, pi minus theta. But then there's another one here, and another one here, and another one here, and another one here, which are off from this one by just a full rotation of the circle. So if you add 360 or 2 pi to it, you come to this cycle, or subtract 2 pi from it, you come to this cycle, and so on. We had similar statements for cosine and tangent, except for small modification. If you have cosine of x equal to some number a, x could be cosine inverse of a. That's what your calculator gives you. In the correct quadrant, either 1 or 2. But negative of that also has the same cosine. And in addition, any multiple of the whole circle can be added. So you're working with degrees, of course, is a multiple of 360. And that is the whole range of answers. For tangent, if tangent is given to you, you want to find the tangent. When you plug it in your calculator, it gives you some answer. By definition, that answer is either in the fourth or first quadrant. How about the remaining ones? What can I add to get the other answers? Does anybody remember? Let's remind ourselves. We remind ourselves either through this picture or through the unit circle approach. In unit circle approach, you say, okay, how are we measuring angles? We had a tangent of angles. We had this axis. For that axis if you have an angle theta, you want to get its tangent. Here it is. This is the tangent of theta. Question, is there any other angle that shares the same tangent? Well, yes, this one, this angle also has the same tangent, because when I extend it, I end up same place. I can come back here again and rotate again and so on. So how do I get the second angle? The second angle is 180 degrees more than the first one. So that is just a multiple of a pi. If I add a multiple of pi, not 2 pi necessarily, any multiple of pi would do. So if I have this angle, I go 180 degrees more, I have the same tangent as I had before. Of course, if I continue going and go a whole circle, that's even better. So these are the 3 ways of solving basic. Let me write that one next to this so we can see all of them at the same time. Sine of x is equal to a. The answer to that, we had x was either sine inverse of a plus a whole multiple of a circle. The other answer was supplementary angle of this, pi minus sine inverse of a, and then again you can add any multiple of the whole circle. So here we have summarized how to solve the basic trig equations for these 3 functions. And again, we are skipping the other secondary functions just so that we have a chance of finishing. Now let's go ahead. I ask you to do problems 1 through 8 yourself based on these things, and let me just solve a few other problems. Sorry. Say problem 9. It's asking you to solve 2 cosine of x minus 1 is minus 1.2814. Give answer. It says find all solutions, but the book doesn't want to go overboard. It says find all solutions in, I don't want too many of them, 0 through 360, say. Just let's quickly summarize some stuff from college algebra. If you had equation like 2t minus 5 is equal to 11, how would you solve that one? So add 5 to both sides, is that right? Which in university it says take minus 5 to the other side, becomes a plus 5. So by now you have 2t is equal to 16. Next, you want to get rid of 2. How do you get rid of 2? Divide by that number, and there is your answer. So that section of algebra is exactly the same as here, except that t stands for your trig function. For a moment, don't pay attention that you got some complicated stuff there. Just let it be. Don't try to go for x right off the bat, but just hold on. Say 2 cosine of x. Take your minus 1 to the other side. So minus 1.2814, or add a 1 to both sides, you say. Everybody with me so far? If you have any question, let me know. Now, you do these problems, maybe you want to use a calculator perhaps. Well, what is that? Minus 0.2814. Just as we did here, the numbers might not be all that friendly. How do I get rid of 2? I don't make a mistake of subtracting 2. What do I do? Divide by 2. Divide by 2. So I divide by 2, get something. Now is the time to crank up the calculator. You say, okay, this is x is equal to cosine inverse of, so if we get one answer, it's kind of in a holding mode until we make sure that our answer is the way the book wants it. Like there is some restriction. So give me answers in that. You go on a calculator, you say, well, what is, is it? Let me see if I can set it up in degrees. Okay. So I have 0.1407, and I want to apply cosine inverse of that number. Before you press your calculator, try to push yourself to do at least a portion of job yourself. Which quadrant do you expect to be? To get a negative cosine, which quadrant do you have to be? 2. So let's see if we get it 2. So your calculator gives you what? 98 degrees and some stuff. Okay, this is one angle. Who's the other angle? Two ways to go about it. One is to use this formula until you hit the destination you want. And the other one is just to reason your way to that answer. Let's do it both ways. So I got 98 degrees. You said which quadrant is that sitting in? 2. So I got my 98 degrees, so I do something kind of reasonable here. So it's my 98 degrees. I don't carry everything with me for a moment so that it doesn't get overcrowded. This guy has a cosine that is equal to that. How did we see cosine? We say shadow on which axis? Yes. It is. This is really that number, minus 0.14. That was the angle. That's the cosine of it. Now, which other angle shares the same fate with same cosine? What do I do geometrically? In case I forget the formulas, I can always recreate this. Which way should I go to get the other angle? Very good. Just go straight down. This angle, how do you want to measure it? You could have gone this way, which would have been minus 98 degrees. That would have been great, except that the software is going to tell you what? It's going to have that red mark. So I want this thing in between 0 and 360. I don't like this one. So what is your so what the software wants, it is insisting on between 0 and 360. It says go this way. However, how much of this circle you go, that is fine, but you are allowed to go through circle once in the positive direction. Wherever it hits your angle, tell me. So the second solution for us, how do you find this black angle now? 360 minus 98. Yeah, exactly. So say 360 is 98 degrees short of full circle. And also you make this thing into so what do you get for that? 991 or something. Degrees. Well, because I had cosine equal to that. Cosine of an angle is equal to that quantity. That is where your calculator comes in. You want to get the angle. We are trying to undo the damage of cosine. To undo this, just like in algebra, if you have 2t is equal to 16, to get t, you have to divide by 2. You have to undo the effect of 2. Or in another way of doing this thing is to say what? Say 2 inverse times 2t is 2 inverse times 16. Now 2 times 2 inverse is just 1. T becomes 2 inverse times 16. That's the kind of idea that's behind this notation. As if you are multiplying, but it's not really not multiplication. Cosine of x is equal to that. You want the x itself, you want somehow cosine to go to the right hand side. How does it go to the right hand side? In algebra you would have said divide by it. Now we say multiply or compose with the inverse function. So the same way that you are getting rid of this 2 to move to the other side, you come to algebra, you want to get rid of a function, you compose with its inverse. Same way this division by 2 was the inverse of multiplication by 2. Cosine inverse is the inverse of cosine. So you have that function. Here is to undo it to get to the origin of it. So any of these things, you're asking, how do I know to use cosine inverse? That was our main topic here. If cosine is given, how do you want to find the angle? Well, you have to apply the cosine inverse to find the angle. Okay? So that also explains the reason behind that particular strange looking notation. Why it is minus 1 doing over there? It's really generalization off of there. 10, 11, well, let's do 10 just so that we sine of x plus 3 is 2.0816, etc. Notice that you should be able to read this thing without getting confused as to what is meant by it. On the right hand side there is no room for confusion, that's just a number. What is meant by the left hand side? What do I do first? Do I add x and 3 and then take a sine, or do I take the sine then add the 3? There are two operations, and as usual when you are doing two things it makes all the difference. Which one do you do first? Okay, so here really what is meant is you take the sine and then you are adding 3. Now how do you do this damage of this addition of 3? What should I do? Subtract 3. So this is minus point, what is that? 9184. Again, we try to get some help, an idea about where we are looking at, what kind of answers to expect, some ballpark idea about the answer before we dive into our calculator and start punching numbers and stuff. So, okay, sine of x. How do we visualize sine of x? Sine of x, you draw the unit circle. If you have an angle, you go to the vertical. That is what is meant by sine of an angle. Now, if an angle is sine of an angle is given, you want to find the angle itself, well, you do reverse this process. You draw your circle. So I want to solve this thing. I am on a deserted island. I have no calculator. I'm not a member of the lost crew or anything. I really want to solve this. What do? I draw using a bamboo or something as my unit stick or something. I draw the circle. I have minus 9.1. What do? What does that mean, minus 9.1? Which way do I go, up or down? Down. This is supposed to be 1, so minus 9 point something is going to stop a little bit shy of this point down here. So that is minus 9, etc. I want to find the angle. If I had the angle, I would have taken a shadow. If I have the sine, I get out of that line. I go horizontally. Wherever I hit here and wherever I hit here, these two locations is supposed to be symmetrical. My picture is not that good. These two locations are the angles or whose sines are going to give me this number. Ballpark figure, what kind of answer do I expect? Almost what? This is almost how do you measure that angle? You are connecting this to the origin and you are measuring this. This is your angle. Minus 90 degrees, is that right? Minus 90 is like minus, say, 85 or something. And then this one is going to be then minus 95. Is that right? This is a little bit shy of 90, and this one shy of minus 90, and that is a little bit on the other side by the same amount. Okay, now if I use my calculator, sine inverse of minus 0.9184, so we are just saying it again. So inverse sine minus 0.9184 so my statement is a little bit off. It's not so close to 69, etc. That is degrees. Now there is also this other angle, if you wish. How do I figure out that other angle? So x, one solution we got is minus 66.69 degrees. If I insist on going in this direction, what is my other alternative that I have here? You can say this is the same angle as that 66 degrees. You are that much short of minus 180. So you can say minus 180 plus 66, 69. So you get okay, these are good, reasonable answers. They are perfectly fine, except that what? What did the book want? Yeah, okay, so all of these things have that kind of a restriction on them. How do we cure this? The book says, I don't like this. I want to go the other way. I want to go so how do I cure that situation to get the answer to be positive and in the range from 0 to 2 pi? The trick is here. If whatever answers you got, you can always add multiples of 2 pi to it, or multiples of 360, until the angle comes to the range that you want them to be. So that is the standard way of making your answer submit to the requirement of the problem. Add enough of 360s to it until it does the job right. So I take this, say, if this is minus 113, how much is that one? You have to subtract that from 360. Even if you forgot that formula, you can still say. So if you want in range from 0 to 360, you say, well, you want to go to the other way, so do 360 minus 113.31, figure that out, and for this, it's say I am 66 degrees short of the whole circle. So 360 minus 66, 69, and you find out what that one is. So what is that? Okay, so we did one example from sine, one from cosine. Let's do one example from tangent. If you want any other problem, just let me know. It says 2 tangent of x minus 4 is equal to 1. What does that mean? Tell me how to simplify this to reduce it to the standard form. Tangent of x is equal to what? Yeah, so that becomes 2.5. Is that right? So again, just to get some idea of where we are headed with this problem, this is my unit circle. In that unit circle, this is truly my unit. Then I have an axis for each of these functions. For tangent, the axis goes off of here. Say it again. I add a 4 to both sides. So 2 tangent of x becomes 5. Tangent of x becomes 5 half. That is where we are headed. So 2.5. This is 1, 2, 2.5. So I try to do a reasonable job of what the angle it is I'm really trying to get. So this is that angle. Perhaps, I don't know, 70 degrees or something like that. Any other angle. While we are at it, we might as well catch all of them. This is one angle, but get all the intersection. This is the other angle. So I want that as well as this one. So that's how we do it from picture. Either that, or you have to remember the following. When you are dealing with tangent, you get tan inverse of that number, and then any multiple of 180 can be added. That is what we are doing. That's how we come to the second point. So x can either be tangent inverse of 2.5, which is, so how much do you get? 60. Okay, 19, whatever. Degrees. Now you give me a recipe for getting the second guy. Or, what should I do to this to come here? This is the angle, and then you're just adding that much to it. Yeah. 68.99 plus 180, you get 248. Okay, we handled all the basic cases. Basic cases mean sine or cosine or tangent is equal to a number, and then we know the drill. We have to go through all the song and dance to get our angles. Each case individually has its own recipe. Next bunch of problems. What if I had a little bit more sophisticated equation to handle? What do you mean sophisticated? Like, let's go back to college algebra. Suppose you had to solve 2x squared is equal to 18x. I ask find all numbers x that makes this true. what would be your approach? So we are leaving elementary linear equations, we are going to quadratic equations. The most basic approach, you have any suggestions what to do? Yeah, take everybody to one side. That's the best policy. If you divide by an x, you are depriving yourself of some information. Dividing by 2 would have been fine, but don't get rid of your variables. Okay. Next, what do? You see if you can handle the factorization. So you factor it. And then what? If you talk it out like this, if I have several items multiply becoming 0, then at least one of them got to be 0. Either this guy is 0, which tells me x itself had to be 0, or perhaps this guy were equal to 0 and the culprit was there or the helper was there, in which case x had to be equal to 9. So, solving a quadratic equation by factorization, just remember, in the full scale form of it, if you have no luck with the factorization, you always have access to the following recipe that tells you what the root is going to be in general, even if your numbers were not cooperating or friendly. Now let's go after some simple cases and deal with them one at a time, such as problem 13 says 2 cosine square of x is equal to 1. Let's convert it to a situation that we are familiar with. Instead of that function, this function, let me replace it with something. Let me call it t. I'm replacing my trig function with just letter t so that I don't get sidetracked with stuff. That was being squared, so my t is being squared. Well, how would you have handled this thing in your Algebra 1? We could do it like that, but that's going to be a little bit overwhelming. It's like killing a mosquito with an elephant gun. So we just divide by 2. Take square root. Is that right? We pick any one of these things. So here when you say 2 cosine square of x is equal to 1, you mean cosine square of x is equal to 1/2, which means cosine of x plus or minus that number. So for a while we don't pay attention that we are dealing with the trig function. We go ahead about our business for isolating that whole thing before we try to attack and try to get the x itself. Now there are 2 cases. In order not to get confused with the possibilities, we might separate them and track them individually. Now, this happens to be a famous angle case, so perhaps you can avoid using a calculator. It's all up to you. Still, we want our answers to be in 0 to 360. So what angles are there whose cosine is radical to over 2? 45. Who's the other guy? Here's a quick dirty way of getting it. You know 45. You know cosine is on the horizontal axis. This is the cosine. Who's the other angle? Has to be down here. Is that right? To share the same shadow, has to be minus 45. But the book says, don't give me minus, give me plus. So what do you say? If you want to go all around until you hit this spot. Well, it's 45 degrees short of 360, which makes it 315. Case 2. Cosine of x is minus radical 2 over 2. That is, your cosine is negative. That had to be this angle or the following angle. First one, the smaller one, what is that one? It's 3 slices of a standard pizza. And the second one, a half a circle followed by 45 degrees makes it 225. Okay? So when you have higher power equations, you have a number of cases to follow. Each of them then leads to a number of roots themselves. So you have a sequence here, and you have another sequence here, and from all of them you choose the one that the text wants, which is like 0 to 360.
You decide between the two, depending on what it would have.
Well, all of these things are, all of them are fair game. We have four infinite sequences of answers. From those 4 sequences, we pick the ones that fall in the range that was required. So it was
So the final answer would have been
any of them.
would have been x equals 45.
Final answer means any of these 4 is fair game. All 4 of them got to be there. Okay?
All of them to be there?
Uh-huh. And that's the whole issue, that we have a whole bunch of angles. All of them fit the bill. All of them are acceptable. And so let's see if we can squeeze one more of these problems. The other ones that are straightforward quadratic, if they factor, fine. If they don't factor, well, you use the quadratic formula and calculator, and then you'll be all set. Some of them you require a bit more finesse, like 20. 2 sine of t cosine of t plus 2 sine of t minus cosine t minus 1 equal to 0. Again, your knowledge of algebra 1 or 2 is essential here. Do not get sidetracked by the trig stuff. Just make up names for them. Let's call this thing A perhaps. Let's call this guy B. So far I have, what do I have? 2AB. Who is this one? 2A. How about this one? So we kind of remove the clutter a little bit to see the tree is separate from the jungle. Then we ask, well, in algebra 1, what would I have done with this thing? What are the skills you learn and practice there? Well, combine, what do you mean? We want to solve an equation. Equations, anybody? What to do here? We want to factor, huh? We want to factor. Tell me how to proceed with factorization of this stuff. Just about anything you would do will work. There is no way of missing this. So suppose I ask you factor something from these two. What is the common expression in both of them? P. If I factor it, what is left? Well, 2A. And what's left from that one? Minus 1. What else am I left with? Luckily, just 2A minus 1. Is that right? So this is 2A, this is minus 1. Well, what do we do next? Well, now the common factor is 2A minus 1. Now let me see your skill from algebra. How the factorization going to happen here? B, yeah, excellent. B plus 1 equal to 0. Well, if you wanted to solve this as an equation, you would have said either the first guy has to be 0 or the second guy had to be 0. It's the only way. Product of two things in ordinary numbers, product of a bunch of things is 0 if at least one of those guys has to be 0. Well, what does that tell you? This could only happen if b is equal to -1. This happens if a is equal to 1/2. Now you go back, so who is a, b anyway? My b was really cosine of angle. Cosine of t is equal to -1. What are the angles whose cosine match -1? Again, is it? Say it again. Pi, 180. Just one of them. I mean, if I had another number, there would have been a sister down here, but this is a so-called double root. But let's just keep moving. This t, 180 degrees. That's the only one. Kind of a extreme case. So one answer comes in. If a is a half, who was a? A was sine of t. Sine of t is a half. Well, what angle is it whose sine is a half? We have seen this plenty of times. 30 degrees. And its supplement, which is 150. So the angles in the first quadrant which fit the bill are these. If you want, the angles in the first circle. If you are willing to go further, you add multiples of 360 and then you are all set. Okay, so you do need to practice as many of these things as you can afford to. So you do 2.5 and review section, chapter 2. We are going to move on to law of sines and law of cosines on Friday. Good luck.